Are aliens building star-sized power plants? The shocking truth behind the 7 infrared stars and the search for Dyson spheres. In the heart of deep space, beyond the shimmering clouds of cosmic dust, astronomers have encountered a mystery so profound it may redefine our place in the universe. 7 stars, all relatively close in galactic terms, are emitting unusual levels of mid-infrared radiation, energy signatures that defy explanation by natural astrophysical processes. These anomalies are not random. They point to a tantalizing possibility that has captivated scientists and dreamers alike for over half a century. The existence of Dyson spheres, hypothetical megastructures built by advanced civilizations to harness the total energy output of their host stars. Today, for the first time, these theoretical constructs are not just science fiction. They are plausible. They are potentially real. And they might be hiding in plain sight, just 900 light years away. Shooting star Dyson spheres. Science fiction or scientific reality. First introduced by theoretical physicist Freeman Dyson in 1960, the Dyson sphere is a proposed solution to a civilization's exponentially growing energy demands. The idea was an expansion of Nikolai Kardashev's famous scale, which classifies civilizations by their ability to harness energy. Type 1 civilization harnesses all available energy on its planet. Earth is Type 0.7. Type 2 civilization uses the full power of its host star, Dyson sphere territory. Type 3 civilization commands energy at a galactic scale, manipulating entire stars or galaxies. Dyson proposed that a sufficiently advanced species might build a swarm of solar collectors orbiting their star, a Dyson swarm, or even a full Dyson shell to capture its energy output and convert it into usable power. These constructs would block or absorb much of the star's light and re-emit it as infrared radiation, precisely the kind of emission astronomers are now observing from 7 specific stars. Telescope the 7 stars, a cosmic anomaly. Recent studies leveraging data from powerful space telescopes like Gaia, TESS, and WISE analyzed nearly 5 million stars to search for technosignatures, unusual indicators of artificial constructs or activity. After refining the data through advanced filters, scientists found 7 red dwarf stars with highly anomalous behavior. They emit up to 60 times more infrared radiation than expected. They show no known signs of natural explanations, such as dust clouds, star spots, or binary interactions. They are all M-dwarf stars, cool, small, and long-lived, making them ideal energy sources. These are not just random outliers. The pattern of excess radiation aligns almost perfectly with theoretical models of Dyson swarms, structures designed to harvest solar energy and re-emit it as mid-infrared heat. Comet, could they be natural phenomena? Skepticism is an essential part of science. Researchers have considered and systematically ruled out various natural causes. Protoplanetary disks? The stars are too old. Binary eclipses? The periodicity and emission profiles don't match. Interstellar dust? The temperature of the emissions, 25 degrees C, is inconsistent with dust-heated light. Background contamination? Eliminated by astrometric and optical follow-up. What remains is not definitive proof, but a strong technosignature candidate. That's why the astronomy community has shifted its focus to these stars, urging further investigation. Brain, how do we detect a Dyson sphere? Detecting a Dyson sphere is not like seeing a structure directly. These are cosmic megastructures far beyond our visual range. Instead, scientists rely on indirect clues. 1. Mid-infrared excess radiation. Dyson spheres would absorb visible light and re-emit energy as heat. Excess infrared in the 20 to 50 micron range is a telltale sign. 2. Optical dimming. Some stars appear to flicker or dim in irregular patterns. This was famously observed with Tabby star KIC 846-2852, which dimmed by 22% without explanation. While later attributed to dust, it sparked renewed interest in technosignatures. 3. Missing stars. Incredibly, studies comparing century-old sky maps with modern data have found stars that have vanished. No explosions, no fading, just gone. Could some stars be artificially shielded? 4. Hydrogen alpha emissions. This key spectral line helps identify natural stellar activity. If missing or anomalous, it may suggest that visible light is being absorbed by an artificial structure. 5. Astrometric wobbles. Unexplained changes in stellar motion or positioning may hint at gravitational influences from large artificial constructs. Satellite, the role of the James Webb Space Telescope. Enter the James Webb Space Telescope JWST, our most powerful eye on the cosmos, designed specifically to probe the infrared spectrum. JWST has already made major discoveries, like detecting biosignatures on exoplanets and analyzing the atmospheres of alien worlds. Its mid-infrared instrument, MIRI, is uniquely equipped to analyze the spectral fingerprints of Dyson spheres. What JWST can do: pinpoint unusual heat emissions, separate artificial heat signatures from natural stellar processes, detect anomalies in the spectra of stars and exoplanets, look for artificial light or heat pollution on planetary scales, help determine if missing stars have been obscured by artificial constructs. JWST is already observing the 7 mysterious stars. Preliminary results have confirmed their infrared emissions are not from natural dust, and follow-up observations are expected to yield more concrete conclusions. Globe Showing Europe-Africa Case Study. JWST's success with K2-18b. JWST has also proven its ability to detect biosignatures, chemical fingerprints of life. In the case of K2-18b, a super-Earth in the habitable zone of a red dwarf star, JWST identified water vapor, methane, ammonia, hydrogen-rich atmosphere. These compounds, especially methane and ammonia, are considered strong biomarkers. On Earth, methane is a major byproduct of biological life. K2-18b, located 124 light-years away, is likely a Hycean planet, a water-covered world with a hydrogen-rich atmosphere. It represents the most Earth-like atmospheric composition found so far on an exoplanet. The success of JWST in this domain proves one thing: we have the tools to detect not just life, but potentially civilizations. DNA Dyson spheres and the fate of advanced civilizations. Why would aliens build Dyson spheres? To sustain energy-intensive computation, e.g., simulations, AI, interstellar communication. To power planetary engineering projects. As part of a stellar engine to move their solar system. To store energy for millions of years. And if they exist, what does that tell us? That life can survive past its technological adolescence. That spacefaring civilizations are out there. That intelligence may be more common than we thought. If even one of these 7 stars turns out to be surrounded by an artificial megastructure, it would constitute the first confirmed contact with extraterrestrial intelligence, not by message, not by ship, but through the telltale heat of alien engineering. Rocket, what comes next? The astronomy community is now focused on 3 critical questions. Can the JWST confirm an artificial origin of the emissions? Are there more such stars, perhaps hundreds or thousands, hidden in our sky maps?